Hello. Refining of edible oils and fats. We will discuss today how to refine oils and fats in the industry. My name is Amit Mukherjee, Assistant Professor, Department of Food Technology, Haldia Institute of Technology. So let us see what is refining. To begin with, uh, we must know what are oils and fats and what among them are edible, because oils are also there, which are called petroleum. Uh, so edible oils and fats differ from petroleum products in various aspects. The oils and fats, these are grossly hydrophobic. According to the definition of edible oils and fats, they are hydrophobic in nature, obtained from living cells of plants, animals, and microbes, and are non-polymeric macromolecules of moderately high molecular weight. The oils and fats are either liquids or solids. That is the major difference with petroleum. Though various petroleum products are there, but fuel petroleum is commonly a liquid substance. But edible oils and fats can also be a solid or semi-solid plastic substance, depending upon the temperature at which they are stored. The oils are commonly liquid at room temperature, precisely at 25 degrees centigrade, and the fats are solids at that temperature. The oils and fats are members of a broader class called lipids in biology. Next, what are oils and fats and what this is being continued? Uh, okay, these are very simple observations. However, what we have uh, said so far uh, regarding oils and fats which are edible in nature. Uh, Oils and fats in terms of their physical characteristics and distinguishing them from fuel mineral oils or petrochemicals, while distinguishing them from mineral oils, we have given some identification distinction, uh, and those are um, discussed just now. However, what we consume uh, as oil or fat is only one class of biological lipid. Willfully consumption means when we consume, suppose, butter or shortening substances, these substances, when we consume them as lipid, we consume a particular type of compound which is called triglyceride. Triglycerides are willfully consumed and are edible oils and fats. When we consume a food material containing lipids, lipids of biology, a large number of different uh, lipid substances are there in various quantities, differing in percentages. We do not have any choice because a food material contain all those substances. But when we add lipid to our foods at any stage of processing or during consumption of it with some visible fats, we only select triglycerides, also called triacylglycerol or simply TAGs. Therefore, refined and purified edible oils and fats are triglycerides. They all efforts made to isolate edible oils and fats from a crude oil or fat simple uh, are to separate other naturally existing classes of lipids from the triglyceride component. We collectively call such efforts refining. So, purification is needed because a biological lipid contains not only the triglyceride, though triglyceride is the major component of biological lipid, but a large number of different lipids except the triglyceride are also present. So when we consume willfully lipid or edible oil or fat, we need to separate all those substances which are called impurities to the oil. Because suppose a phospholipid though do not cause does not cause harm to the body, but it is not edible oil or fat. We willfully do not consume a large quantity of phospholipids as we do in case of triglycerides. All efforts made to isolate edible oils and fats from a crude oil or fat sample are to separate other naturally existing classes of lipids from the triglyceride component. We collectively call such efforts as refining. So, refining is needed to separate other lipid substances from the triglyceride component. No free fatty acids, no phospholipids, no hydrocarbons, sterols, etc. are edible for us. We do not consume a large quantity of free fatty acid as lipid. We do not consume phospholipid or sterol, but we consume triglyceride. Though they are utilized, these substances are utilized, or many remain present in our foods in minor amounts and are not completely toxic to our body at that level. We consume them in minor quantities, but we do not consume them in larger quantity. We fry our foods with vegetable oils, that is pure form of triglyceride. We use shortening substances. We use shortening substances in greater amount in our bakery product. These are pure triglyceride. We produce, we prepare pastry and cake creams for direct consumption, another pure form of triglyceride. We consume butter with our bread because in butter, the lipids predominating are triglyceride. However, butter is a natural substance extracted from milk, bovine milk, which contains also water and also some amount of other lipid substances. Lecithin, which is a phospholipid, very common name in food processing industry, and it is also emulsifier or edible waxes, which are used as coatings for fruits in controlled atmosphere storage for controlling respiration and perspiration of water, or mono and diacylglycerols. These are called MAX and DAG, are also emulsifier, are only used as food additives in minor quantities. They are not consumed in higher quantity as lipid or edible oil or fat. A large number of plants produce seeds and fruits which contain very high percentage of lipid. For example, soybean, cottonseed, sunflower, flaxseed, sesame, mustard, oil palm, cocoa beans, peanut, olive, coconut, etc. Parts of cereal grains like bran of rice and germs of corn and wheat also contain good extractable amounts of oil. The fatty tissues of land and marine animals isolated from carcasses are sources of animal fats. Beef, hog, mutton, chicken, whale, etc. are common sources. Whale is the marine source. Marine fish and their livers, fish liver oil, are also sources of oils. There is a basic difference between the land and this marine fat, because land animal, uh, the sources, when the sources are land animal, it is a fat, solid in nature. However, marine fats are oils, that means liquid at room temperature. They contain very high percentage of vitamin A. Marine fish and the livers are sources of oils as well as vitamins. Haddock, tuna, sardine, cod, etc. are marine oil sources. So this is the picture of rice bran, corn germ, uh, coconut, copra, also sometimes it is called copra, cotton seeds. Cotton seed oil was the first such oil used in the in the food processing industry and in large scale preparation in the Western countries. But after soybean was found to be good for human health, uh, the soybean oil production predominated, and it is the age of palm oil. Nowadays, throughout the world, palm oil is used in larger quantity. So these three oils, soybean, cottonseed, and palm, they are very important edible oils extracted from vegetable material. Flax seeds, palm kernel, rapeseed. Rapeseed has certain problem regarding the toxicity of the uh, solid in the solid component of the seed as well as within the oil as fatty acid, erucic acid. So rapeseed is a genetically modified variety which is called canola nowadays is which is produced. First of all, it was developed in Canada and now it is consumed throughout the world. Also, these oils are used for the preparation of shortening substances by hydrogenation, and sesame seeds also another important oil seed. Marine fishes, sardine, these contain high percentage of oil. They can be classified as high oil and high vitamin A potency and moderate to low such substances. So in this way, they can be classified. Their quality of oil extracted from them can be classified in that manner. Tallow, which is a beef fat, algae oil, microbial oil, uh, very good quantity, high quantity of oil can be extracted from microbial sources. However, there is some perception uh, for the consumer that microbial products which are not hygienic, due to that concept, uh, microbial oil nowadays is not, till date is not so popular. However, they also produce very high percentage of triglyceride. A triglyceride is a fatty acid triester of glycerol. In the following tag molecule in the picture, the hydroxyl of glycerol carbon 1, 2, and 3 are esterified with palmitic, oleic, and linoleic acids respectively. A triglyceride molecule as given in the diagram here. So fatty acids quality also dictate over the quality of the edible oils and fats. Not all fatty acids, when present within the triglyceride molecule, uh, represent edible oils and fats, but a straight chain monocarboxylic uh, fatty acid with or without unsaturation and without the presence of epoxy, uh, chloride, etc., those substituents within the fatty acid chain are called edible oils. Those fatty acids are edible oil fatty acids. Refining of edible oils and fats follows one of the two processes. One is chemical refining and physical refining. There are two methods of refining of edible oils and fats. One is chemical refining, another physical refining. The types and quantities of impurities present in the crude oil, an oil which is just extracted by solvent extraction, is called a crude oil. Now, an oil being crude or refined also depends upon the methods of extraction used. In case of pressing operation, when we apply a pressing operation to extract the oils from vegetable seeds, the impurities collected with the actual triglyceride portion is very low, and that is why we can directly consume them without refining, and only after a filtration which separates out the solid fraction of the seed, and we can directly consume them because impurity fraction is very low due to this pressing operation. When solvent extraction is used, however, using a solvent like hexane, commercial hexane, the impurities collected are very high. Impurities means those lipids which we do not willfully consume. For example, phospholipid, free fatty acids, sterol, hydrocarbons, even the color, pigments, various pigments, darker color in nature, make the oil darker. Those are uh, called impurities. When solvent extraction is used, we necessarily require a refining stage after extraction of the oil. However, pressed oil, for example, ghani oil, mustard seed oil, ghani oil, is not refined. Even fats extracted from the land animals, those are highly pure in nature because those fats are deposited on the in the adipose tissues, and that is why they are separated, already separated from other impurities, and need not be refined. However, oils extracted by solvent extraction require that refining operation. Two methods of refining are there. One is chemical refining, another physical refining. The chemical refining is suitable for oils with larger amount of free fatty acids and gums. Gums means phospholipid. The equipment required for the process is cheaper because that is the age-old technique by which the impurities are separated from the triglyceride fraction of the oil. And you can use a batch uh, uh, refiner where an open kettle can be used, and that is quite cheaper. Low grade oil can be treated by this chemical means to produce a very high grade refined oil, but produces effluent because soap stock is generated by caustic application in the chemical refining, and that causes environmental pollution. Very high BOD and COD load effluents are generated. That is one major problem with chemical refining. Physical refining, physical refining is economical with crude oils containing lower free fatty acids and gums. When the free fatty acid content, all such oils, crude oils which are extracted from vegetable oil seeds, contain to some extent free fatty acid, either uh, very high or moderate or lower percentage. So these free fatty acids are necessarily to be separated because free fatty acids are easily oxidized as compared to triglyceride containing the free fatty acid in the esterified form. Free fatty acid causes problem to the health. A huge quantity of free fatty acid if consumed, it causes acidity to our body. So free fatty acid is objectionable. However, when the crude oil contains very high percentage of free fatty acid, it is very difficult to separate them by physical refining because physical refining differs from chemical refining in the sense that the former uses a high vacuum, high temperature steam distillation, steam stripping operation, where the free fatty acids are treated at high temperature under vacuum to separate out as fractions. Fractional distillation, it is comparable, though it is not similar to a distillation process, but comparable to a fractional distillation where free fatty acids are evaporated and separated from the triglyceride fraction. But if quantity of free fatty acid is high, You require rigorous treatment of the oil in terms of vacuum application and temperature. Very high temperature is used, 260, 250 degrees centigrade. At that temperature, there is enormous chance for the triglyceride to be decomposed and produce further quantity of free fatty. So oil yield becomes lower at high temperature, extensive refining condition. Free fatty acids, if present in lower quantity in the oil, crude oil, that oil is good for refining by physical means. No effluent is generated because you are getting all those free fatty acids as byproduct of the refining operation by distillation. And also, the gums should be lower in quantity. Why? Because a primary requirement for physical refining is that the gum quantity of the oil before going to steam stripping operation should be low, less than 10 ppm or so. If gum present, that means phospholipid if present in higher percentage during this physical refining operation, they arrest water because they are emulsifier in nature. They also arrest water and bind with the oil, and that water prevents the distillation process to occur with very high efficiency. uh, Causes no environmental pollution. Physical refining has no such problem like chemical refining because it does not generate soap stock by chemical reaction. Apart from these, some oils are necessarily to be treated by chemical means due to the presence of typical impurities. For example, cottonseed oil containing gossypol. You cannot treat cottonseed oil, cottonseed oil by physical refining method because the gossypol is not separated. It is a pigment and imparts very dark red color to the oil. Separation of gossypol is not possible by bleaching operation, which is one step, important step in the refining process, both in case of chemical refining and physical refining. You need to separate gossypol by using alkali. When sodium hydroxide solution is added, this gossypol is only separated. Two successive stages of chemical refining, namely degumming and caustic refining, together act on the gums, both hydratable and non-hydratable. One, gums or phospholipids can be classified as hydratable phospholipid and non-hydratable phospholipid, that we may discuss at a later stage of our this discussion. The and thus removal of higher percentage of gums and phospholipid is easier in this process. So uh, degumming and caustic refining. In case of chemical refining, we are going into that. Two such successive stages. Once degumming removes the gum or phospholipid, and alkali refining, it removes the free fatty acid. However, when alkali refining is done, it helps to separate out the residual amount of gum which is still present after degumming operation. So both these two processes together help removal of gum. That is one advantage of chemical refining operation, which is not possible by physical means. So if the crude oil contains very high percentage of gum, you require extensive degumming operation because it is mandatory requirement for physical refining that the gum content should be less than or equal to 10 ppm. It is better to have less than 10 ppm, but up to 10 ppm is allowed in case of physical refining. A mandatory requirement for physical refining of 10 ppm or less residual gum by degumming alone limits its use for crude oils with very high hydratable and non-hydratable gum content. That is why you require some specialized technique if the gum is major part of the gum is non-hydratable. Sorry, major part of the gum is non-hydratable. You require extensive degumming operation. That means acid degumming or a specialized type of degumming operation, dry degumming, whatever, you to separate out this non-hydratable portion. So it induces cost to the industry to reduce the gum content to that level. In case of chemical refining, you need not do so because alkali refining is there, which balances everything regarding gum content. Once alkali refining is done, the residual gum content automatically is lowered to the desired level. Stages of chemical refining. One is crude oil. First of all, we are taking crude oil. Then we are doing filtration. Filtration is needed because in the tank, though the solid material separates at the bottom, solid means coming from the seed, which already in finer uh, uh, shape, these solid substances from the seeds which float within the oil are settled, but a filtration operation further uh, ensure the oil to be free from these seed particles. And then the first stage is degumming operation. The first stage is degumming operation. Okay. Now degumming, that means to separate the phospholipid, we perform this degumming. In case of uh, if the gum present is most of the gum is hydratable, we use the water degumming. If the gum is non-hydratable, major part of the gum is non-hydratable, we need some acid degumming operation, uh, followed by a caustic refining. This is sodium hydroxide solution. In this stage, sodium hydroxide solution is used to uh, react with the free fatty acid. This step is also known as neutralization process. Neutralization, that means free fatty acid forms the salt of sodium, that is a soap, though that soap is uh, uh, not that quality which is used in uh, bath soap manufacture. It is a lower grade soap, sodium salt of free fatty acid, which is produced and it becomes solidified by soap formation and can be separated by centrifugation, followed by a bleaching operation. Bleaching is done to separate the pigments. Pigments means the carotenoid pigment, chlorophyll pigment. These are major pigments present in the oil. Bleaching is a chemisorption process, adsorption, uh, chemical bond formation with the bleaching material and the these pigments separates out these pigments. However, gossipol color of cotton seed cannot be separated. It is not having the similar structure like carotenoid. It is a benzene ring with no charges, residual charges like the carotenoid substances, and it cannot form a bond with the bleaching material, gossipol. However, carotenoids, chlorophylls, etc., can be separated by bleaching. High temperature operation. Uh, After the separation of pigments, the oil gets a lighter color. There are techniques by which one can determine in the laboratory the level of bleaching done. That means the color is lowered, low bond color unit, etc. Various such color units are there by which we can determine the extent of bleaching. Once bleaching is over, we do a dewaxing operation. That means it is, though it is not mandatory, if the wax content is very high, then a pre-dewaxing is done just before this degumming operation. And if waxes are still present, we do a dewaxing operation. Otherwise, it is not a mandatory operation. Followed by A deodorization, very important step in the oil refining. Deodorization is done for removal of volatile odoriferous substances. These volatile odoriferous substances are aldehydes, semialdehydes, etc. That means secondary oxidation products of this auto oxidation of lipid, because oil is stored for long time as crude oil within the storage tank, and at the same time within the seeds these type of changes take place by which the primary oxidation products peroxides and hydroperoxides are generated, followed by decomposition of those peroxides to produce secondary oxidation products which are odoriferous in nature, forming pungent smell, rancidity, which we call rancidity. Once these substances are accumulated within the oil, we call the oil has become rancid. So deodorization not only the volatile odoriferous substances, but also sterols and other long chain compounds which are split by this high temperature process, and those are separated by this deodorization operation. Deodorization process is comparable to physical refining because it is also a high vacuum, high temperature steam distillation operation. Crude oils. In case of physical refining, what are the stages? Crude oil is subjected to filtration, similar step to that of chemical refining operation, followed by degumming. That is also the similar stage of refining as compared to uh, chemical refining. However, requirement is the GOM content should be less than 10 ppm, uh, followed by a bleaching operation. See, no, here no alkali refining, caustic refining is done, and then dewaxing, followed by a physical refining, which is high vacuum, high temperature steam stripping operation. So this is the where in case of chemical refining, we separate the free fatty acid. By caustic refining, we are not separating free fatty acid anywhere here. And the last stage is used for separation of free fatty acid. That is the major difference between chemical and physical refining. Free fatty acid still remains even after separation of pigment, waxes, etc. And finally, at the last stage of refining, in case of physical refining, we are separating free fatty acid, and to some extent, it is comparable to deodorization because it also does the uh, action of separation of these volatile odoriferous substances. So it is, in one hand, it is separation of free fatty acid. On the other hand, it is separation of volatile odoriferous substances, sterol, etc. Because the parameters used for both these two types of uh, operations, like physical refining stage in physical refining process and deodorization is in chemical refining process, the parameters selected are nearly similar, though physical refining uses rigorous high temperature, comparably higher temperature than the chemical refining, but these two processes are comparable, stages are comparable. Both these two methods of refining follow cooling. So just after, once this entire process is completed, we use a cooling of the oil, and the oil is called RBD oil, refined bleached deodorized oil, and then polishing, a filtration operation to give a sparkling clear look to the oil, followed by addition of nutrients which were lost by the thermal treatment of the oil during this all these stages. different stages of refining operation. We add vitamins, mostly the fat soluble. Those are fat soluble vitamins, A and D. Vitamin A is used, antioxidants are used, and then the it is taken into the storage tank, from where it goes to the packaging section. Thank you.